So this is 5.1.1, which technically means this is just part 1. There is a part 2 that we will get to next week, which is solving trig equations. Right now, we're just working with manipulating trig expressions, really. Okay? We have a list at the top of your paper that you will want to have by your side when you're doing homework. Okay? Of, what are there? 5 different types of trig identities listed here. And they are all ones that you will want to become familiar with. You'll want to have your notes by your side when you're doing homework because you'll want to have this list. From day 1, I will provide this list on the quiz, test, whatever I do. So you're being told from day 1. Now, that doesn't, you need to be familiar. The more familiar you are with them, the more successful you can be. Okay? So, let's just talk about reciprocal identities. Those should look kind of, even though you've probably never seen them written like that, they should seem kind of familiar. Reciprocal identities. What is the reciprocal of sine? Cosecant. And so this can be expressed, if you notice here, they've got it in 2 ways. So the reciprocal of sine is cosecant. So sine is equal to 1 over cosecant. It could also be the other way in that cosecant is 1 over sine. What's the reciprocal of cosine? Secant. And so you'll notice that a secant could be changed to a 1 over cosine, or a cosine could be changed to 1 over secant. And of course, the reciprocal of tangent is cotangent. And you'll notice the same relationship there. So again, if there's a time we, want to change out, a trig function, that's what you're looking at. Okay? Quotient identities. New, but yet they should make sense. Tangent, we've talked about this. Tangent is equivalent to y over x on the unit circle, right? But if you think about y over x on the unit circle, that is sine over cosine. So, and if tangent is sine over cosine, then cotangent, its reciprocal is cosine over sine. And of course, as all of these I say, I'm not mentioning the theta. Anytime you write a trig function, you should always have a variable there. So don't ever just write sin for sine or cos for cosine. Always put that variable, which the default here is theta. Okay. Okay, now we get to some new ones. Pythagorean identities. Okay. Pythagorean identities, there are 3 of them. You'll want to become very familiar with these. We will use them quite a bit. But sine squared of theta plus cosine squared of theta always equals 1. 1 plus tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta equals cosecant squared of theta. Again, there's really not a whole lot I can explain until we start doing some examples, and you'll see where they come into play. Okay? We've got our cofunction identities. And when I talk about the cofunction identities, the big red flag, so I know when to use them, is when I see this pi over 2 minus theta in a problem. Well, if I see sine of pi over 2 minus theta, that could be replaced with the trig function cosine theta. Okay, so you'll notice sine and cosine connect. Cosine of pi over 2 minus theta is equal to sine. And that's just saying it's off by that phase shift of pi over 2. Tangent and cotangent are interchangeable, and then secant and cosecant are interchangeable. Okay? Usually it's radians, pi over 2, but for the record, what is pi over 2 in degrees? 90? Pi over 2 is 90 degrees. So just kind of for the record, traditionally you'll see it as sine of pi over 2 minus theta. However, if you saw sine of 90 degrees minus theta, that's equivalent. Okay, most things we do are going to be in radians at this point, but not all. And then if my red flag or my big, kind of hello, use the cofunction identity is the fact that there's a pi over 2 minus theta here. Anytime you just have a negative variable, negative theta, then that's your big red flag that we're going to use these even-odd identities. And I don't know if you guys remember anything about a function being even versus odd, but it has to do with its symmetry. If it's even, it's symmetric across the y-axis. But so the idea is sine of negative theta. If you have a negative variable, that is equivalent to the negative of the function, so negative sine. Cosine. If you have a negative variable, cosine of negative theta is actually just equal to the positive cosine theta. Tangent is similar to sine in that it's equal to negative, and then cotangent, secant, and cosecant follow the same pattern as their reciprocals. Again, you're going to have this list in front of you, so it's not about memorizing it. It's just about becoming familiar. Oh, there's a negative in the parentheses. I should go check out my even odd identities. Oh, there's a pi over 2 minus theta. I should go check out cofunction identities. Things like that will be helpful. Okay? Because that's one of the big things I'm going to, probably one of the biggest skills to pick up is how to know when to use what. Okay? Yes?
So how come for how come for cosine and secant, they're positive?
Cosine and secant are positive because they are what we call even functions, in that they are symmetric across the y-axis.
Okay.
And so, because if you think about cosine is the one where at the y-axis it starts up top at 1, right?
Yeah.
And then both ways it would go down and make a hill or a mountain.
Okay.
And so because it's symmetric at the y-axis, it makes it an even function, which has this property then. Okay? Okay, big bold idea here. The idea with the identities is that trig functions can be replaced with other equations that they are equivalent to in order to simplify or solve. And that is all about what this lesson is about. Being able to trade things out and simplify. Okay? So, the best I can do is say, we've just got to start working our way through these. Okay? So example 1. They're asking us to find sine of theta and cosine of theta and they're giving us 2 pieces of information, and that is that tangent of theta is equal to 5, and cosine of theta, is less than 0. It says by using the identities rather than reference triangles. Meaning, they're asking us to use these identities, to practice with the identities. Not go back and try and set up the triangle and 2 sides on the triangle and all that. Okay? So, my goal is to find sine and cosine. I know tangent. And technically I know something about cosine. On some of the problems on this first page, my big hint is going to be, let's start by thinking about a Pythagorean identity. Okay? So, if we look at our Pythagorean identities, there's 3 of them in the upper right corner of your notes, correct? Okay. What information do we know based on example 1? We know that tangent is 5. Our ultimate goal is to find sine and cosine. We'll get there. If tangent is 5, and that's our provided piece of definite information, what would be a good trig identity to use? The second one. The second one because it has no Pythagorean identities. Second one because it has tangent in front of it, yes? So I'm going to start by writing it out. In that, and is it okay if I flip-flop it? And just say secant squared theta equals 1 plus tangent squared theta. Is that okay?
Mm-hmm.
Now, what do we know?
We know tangent. What's it?
Tangent of theta is 5. So I can rewrite this equation to say secant squared of theta equals 1 plus. Okay, if tangent theta is 5, and this is tangent squared, then I am going to say 5 squared, which I wrote as 5 squared. Levi said 25. Same thing, right? And by all means, if I do something you don't understand or whatever, stop me, ask. Okay. Bless you. Clean up that right side. 1 plus 5 squared is 26.
We gotta get rid of that.
Okay. So this is secant squared theta, yes?
Yes.
Which, it's a function squared, but yeah, think about if this said x squared equals 26, what would you do to find x? You would take the square root, right? So since it says secant squared theta equals 26, we're going to take the square root. Now, what is the square root of secant squared theta? Secant theta. What is the square root of 26? Nope, we're going to take square root of 26. I took a square root in an equation setting, so I need to consider the positive solution and the negative solution. Now, notice I said I need to consider. It's not actually equal to both. I need to come up with figuring out, is secant equal to the positive square root of 26 or the negative square root of 26? So what is our other piece of given information here? Cosine is less than 0. That is code for saying that cosine is negative, right? You guys have learned that code along the way. If they say something's less than 0, that's them trying to tell you it's negative. But they won't just come out and say that. Now, if cosine is negative, what's cosine's reciprocal? Secant. So if cosine's negative, what do we know about secant? It's also negative. So secant is actually going to be equal to just negative square root of 26. And that again is because cosine is negative. And we know cosine and secant would be in the same quadrant in terms of positive, negative stuff. Okay. So I did that work. I used the Pythagorean identity. I found secant. Was I supposed to be finding secant? No, we were supposed to be finding cosine. It wasn't for a waste, I promise. Okay, so, and whether you use identity on this next part or not, technically you are using identity, even if you don't think you are. But what is the relationship between secant and cosine? They're reciprocals, right? You've been taught that for a whole chapter now. That's not new news. That's nothing new today. Okay? They are reciprocals. And so if you want to use an official identity, I could use the quotient identity. Nope. The reciprocal identity from above that says cosine theta is equal to 1 over secant theta. Now, you could also pick the other one. Secant is equal to 1 over cosine, but this one just seems easier to me. So, if secant is negative square root of 26, what is cosine? 1 over negative square root of 26. You can have a negative outside of a square root. It couldn't be inside the square root. But the negative is not inside the square root, it's outside. Yes, and I was debating what you were going to complain to me about. So, technically, some people will tell you you can't have a negative in the denominator of a fraction. So, but you could just put the negative out front of the fraction bar or with the numerator. It can go anywhere, okay? Technically, if we're told to rationalize, we can't have a square root in the denominator. But notice I left it, so take advantage and leave it while you can. Okay? So, yeah, if you're going to yell at me about either of those, you're fine. Yeah. Okay, so are we okay with how we got cosine? And as I said, you don't have to write down, to me, that's not about the identity. I've preached to you. Cosine, secant, reciprocals, so if you know one, you know the other. Okay, so this is where we have options. We know cosine. We still know tangent. We still need to find sine. Now, Ross threw out the idea of using a different Pythagorean identity, which works. That is a valid option. It's not the only option. Okay, so Ross, I assume you're saying you're going to use sine squared theta plus cosine squared theta equals 1 is your suggestion. And I'm fine with that. That is an option. I also want to throw out, this is where you have a whole page of identities up there, right? What else could we use if we know tangent and cosine? Could we use a quotient identity? Yes, you can use a quotient identity. Now, neither of those is a more right or more wrong idea. Neither of them are wrong. So neither of them are a more right idea. It comes down to, what did you personally see? They all deal with, but we have a fraction here, so you're dealing with a fraction, So if you saw the Pythagorean identity with Ross and you want to go that way, you can go that way. If you're saying, I didn't see that, I was looking at the quotient identity the whole time, I'd rather go that way. We should all meet in the end, is my point here. Other than it's your first time through, but the point is it could be done both ways. Okay? So, I actually was going to take the quotient identity route, just to show you a different option. You've kind of already seen how a Pythagorean identity works, right? So if we use that, let me write it down. Tangent of theta equals sine of theta over cosine theta. If you want to go the other way and meet me, please do. There'll be good proof that it does work. So fill in what we know. Tangent is 5. Sine is what I'm still trying to find. Cosine is -1 over square root of 26. Yes, it looks ugly, but it's fine because of what we're going to do here. This is sine divided by a value. If it's sine divided by a value, how do you solve for sine? Multiply by that value. Yes, it's a fraction, but I'm going to leave it in fraction form. I'm not going to do anything crazy with it. So if I multiply, that means I'm going to end up taking this -1 over square root of 26 and multiplying over to the 5. So I'm going to have 5 times -1 over square root of 26. Which, what is 5 times -1 over square root of 26? Nope, give me decimal. -5 over square root of 26. And I'm not saying your decimal wasn't equivalent because I have no idea what the decimal is here. Okay. But I was going to go with the fraction. Now, if you did it the other way and you had square root of 25 over 26, realize the square root of 25 is 5, right? It is like a puzzle. It's like a puzzle trying to find all the right pieces to go together. Some of you will like these puzzles. Some of you will not. I'm sorry. I can't hide it. I can't, Some of you don't like the puzzle, these type of math puzzles. So, yeah. Curiosity. Ross, did you end up trying the Pythagorean identity?
I did.
And you did end up getting it?
Yeah, but I got the decimal.
Okay. Yeah, leave it. And that might have been easier to go fraction form this way then. Because I am looking for fraction answers a lot of times. I'm not, unless they give you a decimal in the problem, I'm not usually looking for a decimal answer. FYI there. Right, and that's why I threw that phrase in, because I did just spot a decimal in the next one. So if they give you a decimal, yes, by all means go decimal. Yeah, so yeah, if you and a friend are working together and you're going to argue, no, you have to do it this way, no, you have to do it this way, but then you work out and get the same answer, you could both have right options. Okay? Possible too. Okay, example 2. Given that cosine theta is equal to 0.34. So cosine theta is 34 hundredths. That is our given information. find sine of theta minus pi over 2. Question?
Yeah, so what I was thinking, since we have that theta minus pi over 2, it's kind of like the co-function identity, except for the theta and the pi over 2 are switched.
Okay, so, and this is, I kind of talked earlier that to me there's something grabbing my attention here. And grabbing my attention here is that it's theta minus pi over 2. Now, when I go actually to look at the co-function, it's not quite the same, is it?
No.
But it still grabs my attention, and it's similar, and we're going to make it work. Okay? So they ask us, and there's a couple different ways we can think about this. They ask us to find sine of theta minus pi over 2, correct? Which is very similar to the co-function identity that says sine of pi over 2 minus theta. What is different about those?
Pi over 2 is negative.
Pi over 2 is negative, and theta is positive. So like if we write them down side by side, okay, this is what they give me. This is the co-function identity. We are off by a negative sign. I was getting ready to say, what do you mean you're off by a sign? And then I realized you meant the other type of sign. Okay, we are off by a negative sign, correct? So what we can do is we can essentially factor that negative out. If we essentially factor that negative out, and it's the negative of pi over 2 minus theta, we can write it out front. And actually, I know what I should have done. For understanding's sake, if you're happy with what I just did, fine. Let me take an extra step here if you want to see it. Okay? Here's kind of a connector step if you need it. Theta minus pi over 2 is equivalent to negative pi over 2 plus theta. Yes? I switched the order. Now, if you were struggling, can you see how it's different by a negative sign? So if I take that negative and factor it out, it's the negative of sine of pi over 2 minus theta. According to my identities up above, what is sine of pi over 2 minus theta equivalent to? Cosine. So I can take that sine of pi over 2 minus theta and replace it with cosine theta. What carries down out front? The negative. So we're just kind of taking baby steps to get there. Well, we know cosine is 0.34. So negative cosine is negative 0.34. And that's what we're trying to get to the point of, we started over here, right? It said find sine of theta minus pi over 2. So I took several steps to kind of connect it for you. To show you that, okay, sine of theta minus pi over 2 is just negative pi over 2 plus theta. Then if I factor that negative out, it's just the negative of sine of pi over 2 minus theta, which, according to our identities up above, is cosine. And so it's negative of cosine. But cosine was defined to be 0.34. So negative cosine is negative 0.34.
So what's sine equal?
Mm-hmm. Negative 0.34. In other words, each time it was an equivalent step, right? We just kind of took our steps until we got to a point where, oh, hey, cosine. We were given cosine is 0.34. Plug it in. And that's essentially what I did at the end. Okay? What?
Or it's like, because we know it's sine it's different. We just know that it's going to be the negative of what.
Yeah. And I tried to write out steps to show the connections. For some of you, it's too many steps. For some of you, you need those steps. And this is, I'm teaching to the people that need to see all the connections. If you guys see steps that you can skip, so be it. Okay? You can't, you shouldn't just be giving me an answer. There should always be some kind of steps, but I get that you could definitely skip something here. Okay, example 3. If you'll notice, it's more like example 1. Okay? They want us to find secant and cotangent, given that sine of theta is negative 2/3, and tangent of theta is greater than 0. Again, kind of like example 1. So I'm curious where you guys would like to begin. Okay. Tangent of theta greater than 0 is code for saying tangent is positive. That's their code. Thoughts on where to begin? Levi?
We could do sine squared theta plus cosine theta equals 1.
Okay. Pythagorean identity that involves sine,
Yeah.
since we're provided sine. Okay. And I'm perfectly fine with going that way. The other option you could go if you wanted to, if we know sine, what else do we know?
We know it.
We know cosecant. And is there an identity that involves cosecant? Yes. Now, it all comes down to what do you see, right? They're both, good ways to get there. So if we just go with the idea of, okay, we're provided sine, let's use the sine one. Sine squared theta plus cosine squared theta equals 1. We're going to fill in sine. And when we fill in sine, sine is negative 2/3. It's sine squared, so it's going to be negative 2/3 squared. Still, plus cosine squared theta equals 1. What do you know about negative 2/3 quantity squared? 4/9, right? 2 times 2, 3 times 3. This is 4/9 plus cosine squared theta equals 1. Okay, yeah. I know it says cosine squared theta. Just think of it like x squared. How would you get x squared by itself? You would take the 4/9 and subtract it over. On the left, 4/9 minus 4/9 cancel. Cosine squared theta. How do I do 1 minus 4/9? Okay, 9/9 minus 4/9. Okay, so 1 in terms of ninths is 9/9. 9/9 minus 4/9 is 5/9. Notice, folks, I'm staying in fractions. I'm not going the decimal route. So don't try and go decimals. This fraction stuff is not hard. I'm not doing crazy fraction stuff right now. Okay? I don't think I really do, honestly. But I'm just saying, this is definitely doable fraction stuff for a pre-cal student. Okay? So since it's cosine squared, we're going to take the square root. So cosine of theta is going to be, I heard square root of 5/9. Officially, I need to say plus or minus. Now, what do you know about the square root of 5/9? square root of 5 over
Oh, is it?
3. Could I say square root of 5 over a regular 3? Some of you don't like me right now.
No, you
I wasn't meaning to. I just got some looks on that one like, really? You really just did that? Yes, I did.
If I don't remember to do that, is that like a crucial part of the entire thing? Or will it still?
It's still the right
Yeah.
answer.
Okay, so square root of 5/9 is square root of 5 because that I don't know the square root of that one over 3 because I do know the square root of that one. Now, it's not both positive and negative. It's one or the other. Why do you say it has to be positive?
Because looking up the balloon and stuff, that's just because you can't have a negative on either of them, or else tangent will also have to be, and in this case, tangent is positive.
Oh, yeah. I see what you're saying.
Because if you divide by
Yeah, if you divide cosine and sine and all that, it have to be positive for tangent, it should be positive. You can't have one or either of them.
I'm confused.
I'm confused. I feel like you're arguing exactly where I need you to argue, but you're telling me. So what are you thinking cosine's going to be?
Has to be positive.
I think it's there.
No, because
Yeah,
sine
let's
is also
sine
negative,
both.
so they both have to be negative.
What do we already know about
Yeah,
sine?
they both have to be negative.
Sine is negative.
Every morning.
We already know that sine is negative. Not because they told me it's less than 0, but because they said sine is negative 2/3. Now, how about this? All students take calculus. Could you think that?
Yeah,
And I don't know if you guys were thinking all students take calculus, or were you thinking tangent is sine divided by cosine? Both work. Okay? Whether you think, because if we look here that tangent is sine divided by cosine, that works too. But right here, we need sine to be negative, which is not quadrant 1, not quadrant 2. And we need tangent to be positive, which has to be quadrant 3.
Where cosine is negative.
And so cosine is negative. So cosine of theta is negative square root of 5 over 3. Now, if you thought this way, tangent is sine over cosine, well, it's a positive equal to a negative divided by a what? A negative. So for either of those reasons, I would argue that cosine has to be negative. And they're both valid reasons. I felt like you were explaining my answer, but yet telling me positive. That's where I was like, I think it's there, but yet it's not.
I just missed the sine is negative.
Okay, and that would be why then. You didn't realize that we're told sine is
I know what
negative.
you were thinking, Chris.
Okay.
But yeah, because that root working sine wasn't, so that would also know later on.
Yeah, if we knew that sine was positive, yeah, we would have gone the other way, but yeah. Okay. Now, all of that work, and we technically have not found an answer yet. Yeah. Okay. If we know cosine,
No, we know
Secant.
secant.
reciprocal of cosine is secant, is one option to go with this. And so secant theta is 1 over cosine theta, if you officially write it out, so secant theta is 1 over negative square root of 5 over 3. Yuck, what's easier to just say?
Negative.
Secant is negative 3 over square root of 5.
So, can you technically skip that step though?
Yes.
Okay.
Because that's a solid.
I mean, officially, I'm writing it out as, okay, here's a reciprocal identity. That's how I know that if cosine is this, secant is this. But if you know that, I mean, yes, you can just jump right there. Okay, we found secant. We also need cotangent. Okay, so what thought are you using to find cotangent? according to our quotient identity, cotangent is cosine of theta divided by sine of theta. Now, fill those pieces in. So cosine on top is going to be negative square root of 5 over 3. Sine on bottom, what was sine? Negative 2 over 3. I have a fraction divided by a fraction. How do we divide fractions? Multiply by the reciprocal. So, of course it wasn't. Thank you. Annoyed, but not at you. Okay, so
I figured you would have been more annoyed if I didn't tell you, so I was like,
negative square root of 5 over 3 times the reciprocal, so negative 3 halves. The 3's cancel. A negative times a negative makes it a positive. And so cotangent is square root of 5 over 2.
I like that.
oh, dude, Chase, what is it happening?
I'm always
Times 2 over 2 or times
I
negative.
taught myself how to solve root.
Say what?
Times 3 over 2 or times negative 2 over 2.
There's a negative in there somewhere. So yes, I have negative of 3. It's negative 3 halves. How's that?
So what goes in the denominator to be a 2?
Because my 3's can cross cancel here,
Oh, okay. Yep.
and it's just square root of 5 over 2.
Oh.
Okay. If you'd like to start looking at the beginning of homework, you can. Okay? You can only look at the beginning, though, if I recall. So, it's page 410, 1 through 37 odds. My plan tomorrow, I don't think we'll do all of the back pieces. We'll just pick a handful to get you guys ideas because it just comes down to practicing. I cannot stress enough that the more you practice it, the more you'll figure out some tricks, you'll figure out some pieces, and we'll go from there.
5 steps.
And there's just 5 things to consider. We don't actually take all 5 steps.
We have to factor
So, okay. So that is the plan for tomorrow. And then maybe if I get a couple of quizzes made up, you guys can see quizzes tomorrow.
Oh, yeah. They're all in Skyward, right?
Yes.